Pizza time is always a happy time, and I know you're happy seeing me bringing pizza to you this moment. Let's enjoy this pizza together. This is mathematics pizza number 43, and we have a pizza from what? From the topic indices that we want to enjoy together. If you're ready, let's begin. All right, simplify 9 raised to power 1 over 4 times 27 raised to power 1 over 2 divided by 81 raised to power 1 over 2. Now, if you look at this question, we know that this question is from indices, just like I've said. And what part of indices? Fractional indices. So if we put this down, 9 raised to power 1 over 4 times 27 raised to power 1 over 2 divided by what? 81 raised to power 1 over 2. I want to solve this. Now, the first thing that may come to someone's mind is to apply the rule in fractional indices. Maybe someone may decide to write this 9 raised to power 1 over 4. The person may just say, let it be 4th root of 9 raised to power 1. Okay? If you do this, there will be a problem, because the 4th root of 9 is not what? A whole number. So you see, this cannot be the approach. On a second thought, we know we can still reduce 9 to power of 3, yeah, so that we have 3 raised to power 2 as 9. So I think we can do that. Okay, so we have seen what to do on 9. Then what of 27? 27 raised to power 1 over 2. Now 27 raised to power 1 over 2 can be written as square root of 27 raised to power 1, right? But square root of 27 is not also a whole number, because 27 is not a perfect square. So if we try to write it in this form, we'll now have another problem. So what do? We can still write 27 to become 3 raised to power 3, right? Okay, so what of 81? If we look at 81, we can discover that if we write 81 as 81 raised to power 1 over 2 as square root of 81 raised to power 1, 81 is a perfect square, because square root of 81 is what? 9. Square root of 81 is 9, and 9 raised to power 1 will give us 9. So we can actually use the principle of fractional indices here directly, and we'll not have problems. So let's implement everything we have just done. Yeah, the law, problem is usually implementation. So let's implement that. Now 9 can be written as 3 raised to power 2. Then we have another power, which is 1 over 4. So we have that times 27 can be written as 3 raised to power 3, and is raised to another power 1 over 2. 3 raised to power 3 is 27. So we have this. Okay. Then 81 can be written as square root of 81 raised to power 1. We know when you raise a term or a number to power of 1, it still remains the same. So we write this as 81. As 81. We know that when a number is raised to power of half, it's the same thing as square root of the number. When you raise a number to power of half, just like we have a square root. Now somebody may be wondering, why didn't I write this one as square root also? It's because 27 is not a perfect square. We just explained that now. So let's move. That means I can multiply this using power of power in indices. A raised to power m, all raised to power n is the same thing as a raised to power m times n. So 3 raised to power 2, all raised to power 1 over 4. Same thing as 3 raised to power 2 times 1 over 4. That will give me 3 raised to power half. Okay? So if we apply that there, we are going to have this as 3 raised to power half times. This will also be 3 raised to power 3, all raised to power 1 over 2 will be what? 3 raised to power 3 times 1 over 2. That will give you 3 raised to power 3 over 2. Okay, so this becomes 3 raised to power 3 over 2. Okay, divided by square root of 81 is 9. It's 9. Okay, so we will still not be able to apply the knowledge of fractional indices here. It will not be possible, because of what? We can see that we cannot find square root of 3, because 3 is not a perfect square. Right, we can find it will be in decimal, but our interest is not for us to have an answer in decimal. So when we now discover that we cannot be able to express this in square root form, because 3 is not a perfect square, and also the same thing here. But if we look at this, This is an index term, an initial term, and they are multiplying. The bases are the same. Now we can apply the first law of what? The first law of indices, where we have a raised to the power m times a raised to the power n is a raised to the power m plus what? N. If the bases are the same and the operation between them is what? Multiplication. We bring them under a common base and then add their powers. That's what we do here. The bases are the same. The operation is what? Multiplication. So 3 raised to power 1 over 2 times 3 raised to power 3 over 2 can be written as 3 raised to power 1 over 2 plus 3 over 2. We're going to do that here now. So we'll bring this up to this place. Let's bring it up to this place. So this becomes 3 raised to power 1 over 2 plus 3 over 2 all upon what? 9. We just explained it now while we are adding the powers. So this will now give us 1 over 2. 1 over 2 plus 3 over 2. When we are adding fractions and the bases, the denominators are the same, we just add the word numerator, the numerators, and bring them under a common what? A common denominator. So this will give us what? 2. So 1 over 2 plus 3 over 2 will give me 2. So I have 3 raised to power 2 all upon 9. You see, this pizza is about to finish. Yeah, it's about to finish. It's about to finish. So just watch out as we finish this pizza. 3 raised to power 2 will give us what? 9 all upon 9. Wow. Our pizza will now reduce to just what? 1 at the end of the day. You can see how lovely today's pizza is. Watch out for more pizzas. Till I come your way next time, keep enjoying our meal from physics, from chemistry, from biology, and from mathematics. Remember, I'm still your sure plug as far as mathematics and sciences are concerned. I love you.